This is a lot of what I've done over my career, just self-development. Go and be really inquisitive. There's a reason why you pursued an engineering degree, and it's because you wanted to learn stuff. You wanted to investigate and innovate and change the world. For me, what I'd love to see more of is that personal investment. Get involved in groups. Follow people who are involved in technology development.
Listen to some podcasts.
Yeah, that's a good idea.
Listen to the Engineering Buzzcast.
3, 2, 1, 0.
Hello everybody and welcome back to another exciting episode of the Engineering Buzzcast. My name is Jacob Primus and I'm joined here today as usual with my good mate and co-host Daniel Hardy. Now today we bring you this episode directly from the WSP office here in the forever sunny city of Gold Coast, Queensland, Australia. Here we've had the privilege of having a good chat with Chris Steer, who is currently the Capability Development Lead at WSP for not only Australia but also our mates across the water in New Zealand. Now, Chris is a bit of a whiz when it comes to all things BIM and digital engineering. Now, you might be wondering, what the heck is BIM? And I assure you, it's not a type of energy drink or sports clothing brand. No, it stands for Building Information Modeling, and it's one of the most buzzing topics across the engineering software space at the moment. Combined with digital twinning, it makes for a truly unstoppable duo. Now, if you like your programming like any insane person does, this episode will tickle your fancy as we cover all things software, digital tools, computational design, and even the use of game engines in civil design. Most importantly, we talk about what it means to have a work-life balance and how one can ensure that they have the right skill set entering this thriving industry. Now, sit back, relax, and I'll let the expert tell you more about it.
Welcome, Chris, to the Engineering Buzzcast. It is good to have you on.
Thank you very much. It's good to be here.
Give us a bit of a rundown of the sort of work you do on a weekly basis with your role at WSP, and what are some of the noticeable and recognizable projects you've been sort of undertaking in the past few months?
Yeah, well, actually, recently it's actually been very project focused. My actual role as a Capability Development Lead, I sit over our roads and aviation civils section. So that's things like road alignments and obviously aviation and anything that's really civil things like signage and ITS traffic signals, that sort of gear. We sort of split into a few different specialties. So aviation group, obviously very specialized. So they kind of look after themselves quite a bit, but kind of lends itself to my background as a road designer. That's how I forged my career. But what that generally looks like is actually trying to understand the capability of one, our staff currently, and two, actually looking at where's all the technology picture of the future. So what software we're using, how does it interact with each other, how does it interface with all the different, because we use so many different pieces of software. How do we get that to actually talk to each other? So we have our design teams on the ground actually being able to design pretty much in harmony with each other, or what we call coordinated design. So that's what the role of capability lead really comes around. It does a lot with dealing with our technology vendors as well. We deal very heavily with Autodesk and Bentley. We also use quite a bit of 12D, which is an Australian-based product, but we've got some guys in Brisbane who are quite in depth with those, so we let them deal with that. But we're more looking down the path of where the global giants are taking us. But at the same time, not ignoring, by any stretch of the measure, not ignoring the local products that have served us well for many years. But it's also trying to have a look at digital requirements coming from our authority clients, so likes of Transport and Main Roads in Queensland, Transport for New South Wales, MTIA in Victoria, same with Department of Transport and Infrastructure, I think that's what they're called now. They've got a whole suite of things that they call digital engineering requirements. So BIM generically is a component or an outcome of digital engineering, but there's a lot of requirements on the accuracy of what we produce and also the data that we put behind that for asset management, costings, procurement. There's a whole pile of stuff that we need to do. So that sort of comes into it as well, and understanding how we're creating and applying all of this data to objects to create what's actually one of the buzzy terms in industry at the moment, is creating things that we call digital twins. So that's kind of the role in a nutshell, is trying to basically distill that into chunks that we can then go and skill our teams up in how to deliver In terms of notable projects, I've actually been the digital manager for the WSP component of the M6 Stage 1 tunnels in Sydney for the last 18 months.
Yeah, cool.
That's been a really interesting project. And if this was a visual medium, we could maybe show some models, but unfortunately it's not. But
One day.
but that's okay.
I'm guessing it's going to be a pretty tricky episode then, because it's all based around like the physical description of things, and you're sort of having to use all these words that can sort of put a picture in people's minds, I guess.
And we'll try to do that, like if we put it in a nutshell, like, explaining to Dan a bit earlier today, what is this thing we call BIM? We're just walking down the road, and I looked at a curb line and said, look, how we used to design things is we define a curb by the front lip of the curb, the invert line, or the flow line, depending on which state you're in as to what they call it, and the top and the back. And then we'd create a surface of that produce cross sections, produce 3D strings. That's what we used to do. Now we're having to go into a world where that curb actually needs to be in virtual 3D world, an actual curb as a 3D model. And it's not just a piece of geometry or a nice visualization. We then have to go through and put all the information pertaining to that curb. So what type of curb is it? Whose standard is it under? Where does it start? Where does it finish? Which road does it belong to? Yeah. All of that asset management type data. So when you hear things and see presentations on things like digital twins and BIM and things like that, there's a heck of a lot of work that has to go on in the background to actually create that data, let alone manage it. So that's primarily where I focus. And with the M6, it's an underground tunnel. It's 3 kilometre long tunnels, 1.5 kilometre on and off ramps back up to the surface, and it's 4.5 k's of bike paths and things like that. It's quite a massive project.
Jeez.
And when you look at a tunnel, what you don't see is all of the heavy lifting. So when you drive in a tunnel, you see a road lines, some nice fancy panels on the side, and if you look up, you might see some jet fans and street lights and things like that. But what you don't see is all of the ventilation buildings and all of the services that go through there, and
let alone like all the wiring and stuff too, I imagine.
All the wiring, all of the fire life safety deluge systems. So we actually have to put all of that into a 3D environment to make sure it all actually fits.
Yeah, okay. Because when you get to big projects, I guess you need to look at it holistically. Otherwise, if one thing doesn't work, you just wasted all this time.
Yeah, it actually costs a lot of money to redig a tunnel. But it's quite amazing. Like it's a really exciting part of industry, because we get to see the sheer size and magnitude of what actually is required 70 meters underground to facilitate 3 lanes of traffic in each direction.
I imagine that's such a game changer too, because you can sort of then work out the requirements a lot more specifically, and they're more precise and more accurate, I presume, which obviously in the long run saves money for the company and the project, I presume, as well.
Yeah, look, the certainty for the construction teams is huge. We can give them proper quantities of things like all the shotcrete they need to line this tunnel. Have a look. We didn't go to the level of things like waterproofing membranes and stuff like that, but if I could show you a cross section of one of the ventilation buildings, I think it's 5 stories high above ground, maybe more, and then almost the same underground in a shaft. Just a bunch of fans and transformers. It takes an enormous amount of power and ventilation for a tunnel.
I did not have any idea that was.
I imagine so much of that is according to safety standards too, and I imagine that sort of makes or breaks a project and how much you have to actually put under the ground in the first place as well. Yeah,
well, there's a number of factors. So you've got to think about the exhaust emissions from vehicles going through there, and then we've got smoke requirements. So if a disaster does happen underground, how do we actually clear the smoke? How quickly do we have to douse that fire? So that's where, on M6, we're doing the alignment in the roads and part of the tunnel lining, or most of the tunnels, geotech and lining and all of the surface works. But we're also working with UGL, doing all the tunnelling systems. We're working with Hassel Architecture for all of the urban design aspects and making it actually look nice. As well as all of the requirements in a normal building, because it's still got to be designed like a normal workplace building, because it's what it is. It's not just an industrial fan that we switch on and it goes really fast.
I guess it just makes it a bit more complex, because instead of being surrounded by air, it's surrounded by metric tons of dirt and piled on top. I imagine puts like a lot of
Yeah.
pressure and stuff like that on it.
There's a lot of pressure, but thankfully through Sydney, there's a lovely material called Sydney sandstone. But there's complications through that too. Like, you know, it's even just in my career, I've still got to learn a lot. Recently, I've learnt about dikes inside geotechnical conditions, and they're like a different strata. So you go through these different zones, like a big fault zone, different materials. The geotech engineers are quite very, very smart people in what they do. And then you get through, we're working with PSM as well. So PSM are doing all the soft ground tunnels, which are self-supporting concrete tubes underground, because they don't have the benefit of being in rock. They're more in the softer soil. So
does that pose more of a challenge, I guess? Yeah,
it would, because I'm not a tunnel engineer, but it does, because they've actually got to work out how to punch a hole through that and support that. This particular area is a fully tanked tunnel, so it's a concrete tube. It's like a tank underground. So it's got to support the stuff above it, and it's in shallower ground as well, so it's not as much pressure.
Yeah,
right.
But we do a ventilation building running straight over the top of it.
So does that mean, like, when you're going through the tunnel, or when you're driving like in the streets above, there's actually entire buildings just dedicated to ventilation for that tunnel?
Yeah. If you know what you're looking for, you'll find them.
That's crazy.
If you don't know what you're looking for, you won't know they're there. And that's the whole idea.
Yeah.
Is trying to assimilate this fantastic engineering marvel, and you don't even know it's there.
That's
It
insane.
used to work pretty well. I didn't even know it existed till just now.
Yeah.
That makes sense.
I imagine that like plays such a big role in like the design process as well, being like, especially if you've got a city above, how much does that affect the beauty, quote unquote, beauty of the area, and
Absolutely.
like the appearance and things like that. It's insane.
How do you filter emissions, and how do you filter all sorts of stuff? It's
insane.
It's super impressive, and until you've actually worked on one of these projects, like this is my first tunnels project, the amount of stuff we've got to do it blows your mind.
Yeah.
Absolutely.
Like a bazillion standards.
Bazillion standards. Yeah, I mean, 4 different asset management standards on one project.
Wow.
Yeah, it becomes a tricky situation. So
I'm guessing like the digital twin aspect of it though would help immensely in terms of according to the standards, because you can literally just send someone a file and be like, have a look for yourself. Here you go. You can see it in the model. It accords to that standards, blah, blah, blah.
Absolutely.
I'm guessing instead of having to send over a schematic like in the past, or here, I'll send you these files and that sort of thing, like that would save so much time.
We send them a federated model now. They look it up. They click on an object. They've got 60 odd different attributes against an object.
Wow.
To say what it is, what its classification is. And then we run through a massive amount of clash detection down to clearances around pipes that are under 200 millimeters in size to make sure that it actually fits. Probably one of the most intricate parts was we were chucking about 2,500 piles through existing road for a geotech improvement system, because we had 132 kV underground line that we couldn't. I think the limit on settlement above that was 20 millimeters. And we're putting 3.5 meters of fill over the existing road to raise it up above flood levels and things like that.
Yeah, okay.
So massive geotech investigation or massive system to stiffen that soil so it's not going to settle and disturb these really high voltage cables underground.
Wow.
We had to try and fit all those around existing utilities and drainage and
I'm guessing there's like a massive challenge as well, being like, what's going to be there in the next 10, 15 years? Like, are they going to have to run a hydrogen pipe through there at one point, or are they going to have to do...
Yeah, wow.
I don't know. I guess that was sort of like the problem with the fibre optic installations in Australia, you know, like having to predict that there's going to be that innovation in the future.
Yeah, that's right. And that's where the beauty of it is now. Like, we've been doing this in the infrastructure space for 9 years now.
Wow.
But what we're doing now, it might seem like a lot of hard work for our teams, but what it does do is give certainty down the track. We used to work on a GIS system that was sort of a bit vague, and it might be there, it might not be there. But now we're getting more certainty and bringing that back into what's an as-constructed model. And that's, if you look around the endeavours going on between all the different states, you'll see Queensland Digital Twin or Brisbane Digital Twin, same with Sydney. They're actually setting up full publicly available environments
Fair income.
where people can go in and actually see where things are actually built.
Wow.
But definitely in terms of public infrastructure and things like Cross River Rail is being built at the moment. There's a lot of information coming out of that But look, we're not really involved in that project, but we're certainly tracking industry on what's happening with that. The same with Queen's Wharf. That was fully done in a 3D world. They were using IFC models. I think Cross River Rail's doing the same. IFC's Industry Foundation Classification. It's a type of open source model format. Using that out of a myriad of software to coordinate, and there's been a lot of connection between the different things on where underground structures are, where tunnels are. It just provides a lot of certainty for the future.
On software, is it sort of standardized across companies? Like, do you guys just all use Revit, or do you guys just all use the same sort of thing? Or
we use a whole pile of stuff.
Yeah.
We do use Revit. We use Revit quite extensively in a number of different ways. We use in different states have different flavors because different authorities have different delivery requirements.
Yeah, that makes sense.
Yeah, right.
So in Queensland, we primarily use, in the roads world and rail, we primarily use a software called 12D for the alignments and the actual formations. And we also use that for drainage pretty much nationally. In terms of civil structures like bridges and major culverts and things like that, we normally use Revit. Although we're doing a lot of work at the moment with Rhino and Grasshopper, so we'll use Revit and Dynamo. So Dynamo is a scripting tool. So we use that in the Revit space. We use Rhino and Grasshopper, which is the same. So Rhinoceros is the modeling package. Grasshopper is the visual scripting or computational package.
Okay.
So we use those. We're starting to look into Tekla as well in that space. We've got a bit of civil 3D coming through in Queensland. Most of our big, massive jobs in New South Wales, we've actually been using civil 3D for a while down there, and then again hooking Dynamo into that as well. And that's been a lot of my focus for the last few years is computational design with civil 3D to create automations and for geometry, and also a bit of data science. So all attribution for our roads on M6 was all automated through Dynamo. And then you go down to Victoria, and we primarily use the Bentley software down there. So Open Roads, Open Rail, Open Bridge. But it's a lot of that's based on history. And how
I've heard that
to deliver.
even like lately they're starting to use programs like Blender and stuff like that. That's previously been used for like video game engines and things like that, and they're starting to model it in that now, which is pretty crazy.
Yeah, we do. Even Unreal Engine. Unreal Engine's being used a lot for the VR stuff that happens. We've got a dedicated Viz team that do that. But Blender BIM, there's actually a BIM side to Blender, and I was at a conference a little while ago, and we've got some great industry friends at Autonomation, a guy called Adam Sheether. He's not in Blender BIM, but he was part of a panel that was actually with the guy who I think wrote Blender BIM.
Wow.
It's all open source. The whole thing, the whole industry is becoming an open source utopia, really.
Yeah, and the thing is, so many people know how to use those open source softwares, which makes it so when new engineers come in, they're like, "Oh, I've done this before. I made a video game in Blender. So I can then use BIM and that sort of thing."
Or you can create things and attach the attributes and manipulate things and go into all of the Ds of BIM. There's a myriad. I think we're up to 10 now.
Okay. What are the Ds?
So the Ds, basically, you go through 1D, which is just an analysis. 2D starts to look at things like your standard drawings and what you'd see as a PDF or a schematic. 3D, obviously, 3D, that's pretty standard. Everything, the world exists in 3D. 4D brings in sequencing. So we'll actually create a sequencing model on how to construct something in a better manner. 5D brings in cost. For estimation, so we can actually look on the fly around how much something's costing and compared to where we are in the construction sequence, what we're predicting that spend to actually look like. So better budgets, better forecasts. 6D starts to look into asset management. 7D is demolition. I can't remember what 8, 9 and 10 are, but there's a lot more.
I keep thinking in terms of digital media, 3D and 4D cinemas and stuff like that. I keep thinking in that. So D, I'm guessing dimensions. So dimensions of the project.
Just a dimension. I haven't got a dictionary in front of me to define dimension, but you think about the fourth dimension in just the general world is time.
Yeah.
So that's where 3 dimensions is your X, Y, Z, or flat plane front or length, width, depth.
Yep.
4th dimension includes time. So time becomes sequencing, like construction sequencing over that, and then you just add the next dimension of cost. How much is this going to cost?
Get super philosophical.
Yeah. So yeah.
So Chris, just quickly, as you know, this is obviously called the Engineering Buzzcast. So run us through what is buzzing in your industry at the current moment. Some of the things buzzing in your line of work could be in terms of new opportunities, breakthroughs in software.
Innovation.
For example, you've briefly just talked about BIM.
Yeah, look, I mean, BIM, like I said earlier on, BIM's an outcome. What we use the terminology of digital engineering. You hear a lot about digital engineering. So you go to Transport for New South Wales, they've got a digital engineering framework. Queensland still call it BIM. Victoria call it digital engineering. Probably the biggest buzz at the moment is all around things like carbon capture, digital twins, and just for a quick brief explanation, a digital twin is literally a virtual representation of a physical asset. But it then goes into, to make that digital twin work, we've got to load a piece of infrastructure with a bunch of sensors or monitoring things, air quality, traffic loads, all that sort of stuff, and Internet of Things. So Internet of Things has been a buzzword for a little while, but it's, you can even connect your fridge to your Wi-Fi at home now. It's like, but that's sort of coming into the domestic market. But yeah, definitely digital twins and definitely decarbonisation or net zero policies, embodied carbon. There's a lot of sort of innovative work going on around that, and that's where the use of that digital twin, that's why we put so much effort into creating these 3D models, because without that, it's kind of hard to get that instant grasp on what's the quantity of concrete we're using in a project.
Yep.
What's the embodied carbon value of that concrete? The opportunities around that realistically come, well, what are the alternatives? We've got a project in New Zealand that's been done, and they looked at using a fly ash mix instead of a standard concrete to actually reduce how much carbon was being used. And they could measure that out of the model straight away. So
because I'm guessing you can sort of just select a surface, gives you the square meterage depth and that sort of thing, and then you can very accurately measure how much you actually require, I'm guessing.
If we're using a model of solids, and some software will use a mesh, which is computationally a solid, visually a solid and a mesh look the same. Computationally they're different. So computationally a mesh is a shell, it's hollow. Whereas a solid actually computationally is solid.
So 3D.
Well, they're both 3D.
But
I think if you looked at an egg without a yolk,
okay,
a mesh is the eggshell without a yolk.
Right.
Solid actually is the entire egg.
Okay, right. So it sort of gives it properties in a sense.
It automatically
density stuff.
Gives it densities, gives it volumetrics and things like that. So I mean, we can compute the volume of a mesh. But if you're dealing with those kind of objects in a model, you've automatically got a volume. You can quickly create that into a tonnage. And you can look at, what's the actual measure from places like ISCA or the International Council of Sustainability. I think it's international. Don't quote me on that. But ISCA actually do a lot of work in sustainability and actually measuring the sustainability requirements of a project. So they've actually come up with some calculations, things like how much carbon is required or how much carbon is embodied in, I can't remember if it's a cubic metre or a tonne of concrete, but it might determine, depending on what the normal quantification method of that material is. So asphalt, we normally quantify that in tonnage. Not sure why they do that in tonnage versus cubic meterage, but they do. And then it depends on the engineer as to what they assign as the density of that asphalt, because you can have a different density range. But even that sort of calculation can be really quickly generated within a model, so we can get a really quick indication of the actual carbon cost of an entire project. Now the systems to do that at the moment are growing, they're emerging. So we've got a few different endeavours in play. We've got a few in-house ones that WSP are building. Some of our competitors have built their own. We've got software vendors integrating like a one-click solution or trying to include a one-click solution to go, well, what's your how many or how much quantity of a particular item or set of items are you using
Yeah, right.
to measure how much carbon we're actually using on that project.
So,
that probably-
these ISCA set the standards essentially
yeah, pretty much.
with their own experimental data or somebody else's experimental data.
I'm
how
not
do they...
exactly sure how they come across that.
Yeah.
But I'm not sure if it's their experimental data or if they're hooked up with a whole pile of universities and societies and things like that.
Right.
But, interesting. But they've been around for quite some time, and I know our guys in New Zealand are using the Australian-based ISCA properties.
Oh, really?
To generate that, and yeah.
Do you think that it'll ever be standardized across the globe, even, or Western countries like UK, Australia, US, that sort of thing? Do you think that?
Absolutely.
Or does that also depend on, I'm guessing, how it's produced in those countries? Also,
I think
changes the standards.
There may be some countries that need to adopt a different country's accepted policy.
Yep.
Obviously, not every country is on the carbon neutrality wave. Not everyone agrees with it, but whether you do or don't, it's a good thing to do. We've got to look after our planet better, and we still need our fantastic engineering marvels that we build. But how do we balance that? How do we make it so that it's not as detrimental to the environment and the place that we live, but we still need things that are going to service us and make our lives easier to live. Yeah. So whether you're in the UK, I know we do a lot of work with our UK people. So there's endeavours in the UK, there's endeavours in New Zealand, there's endeavours in Australia. There's work going on internally for us that's actually hooking all those up together and trying to come up with some sort of standard way of doing things. Now that'll change with regional flavour, but I think in the not so distant future, it's going to become one of the hottest topics and one of the biggest drivers behind more digital twin activities.
Yeah, like on climate change and stuff, like recognizing our societies like making huge steps towards a more sustainable, low carbon future. What role does WSP play in the innovation that's going on in that sector, and what sort of projects are you guys doing to work towards that low carbon renewable future?
We do quite a lot actually, and as a company we've committed to a net zero, or basically reducing the amount of carbon we're using and also recommending, I would say. But we have a 2030 I think policy. It's either 2030 or 2050 policy to basically net zero. That's being driven by our executive leadership all the way up from Canada right through to Australia. Like, we're based out of Montreal, that's where our mothership is, but all the way through to our Australian CEOs made the commitment that we're going to head towards that net zero path as much as possible. So there's actually, we've got working groups internally at the moment that are working on looking at the tools that are actually going to best suit the software stacks that we use and the calculation methods that we use, so we can actually get that on pretty much on demand embodied carbon calculation at a fingertip.
Wow.
So there's a couple of different working groups that have been formed for that internally. Now as those working groups get through their studies and get through the things that they're focused on, they'll actually produce those reports for the rest of the company to use and leverage.
Wow. It's so crazy because it's changing an industry that's existed for thousands of years, doing things usually the traditional way, and then here comes this new thing and it completely changes everything, and it's I guess it's going to be such a fun challenge to like try and work around that and having to adapt those new policies and standards and stuff in terms of sustainability.
Well, definitely for the people that are involved in the digital future. Yeah. People like me, I'm a bit of an old fox. For some people, I'm an old fox. For some people, I'm still a young whippersnapper. But look, even for people like me, it's still quite exciting, because what really drives me in this space is actually getting that information through a lot quicker. How do we integrate? How do we connect all of our tools that we use? A piece of data is a piece of data, and once we understand how we can utilize that piece of data across all the software range that we use, there is so much we can do with that. Because as soon as we can embed that piece, that one little piece, into anything, we can go and run whatever calculations we like on the fly. And that's one of the big challenges now, is in terms of interoperability of the tools we use. And that becomes a mixture of off-the-shelf tools that we'll sit inside Revit, for example. There's a tool that actually does a carbon calculation in Revit, Our sustainability
cool.
team are working on various projects where they get a particular data format dump out of a model and then put that into their software to produce the carbon calculations.
That's so cool.
But it's a really exciting time
Yeah.
to do this. And as a road designer, I was always pretty keen on making my life easier every day. I'm not a programmer. I'm not a coder. But things like visual scripting and some basic Python and things like that just changed the game.
Yeah, I was going to ask, what sort of programming languages do you guys use? Do you use C? You just mentioned Python. Then is there another programming language that you guys use that people might not know about?
And how do you apply those as well?
Yeah, look, a lot of the way we apply them. So for my day-to-day, like I use Dynamo. I'm actually having to start learning again in other tools. And one of my colleagues, who's my counterpart in our Bridges Maritime Structures team, he's said to me he's committed to learning either Dynamo or Grasshopper next year.
Okay.
But a lot of the stuff we base on, because we're a very Windows-based organisation, all of our stuff is actually Windows. So C#.NET is very prevalent for the coding people that are using mainstream. So pretty much all of our software, except a few, have what's called an API, or an application programming interface.
Okay.
Where we can extend the capabilities of what the software writers and vendors have actually put in there.
Yeah.
Is that sort of a little bit like front end going into back end, a little bit sort of blending between those two?
Yeah, so very much going into back end. So obviously a software vendor like Autodesk or Bentley, they're going to write a piece of software that's suitable for general use. They obviously can't satisfy all of our needs and various other places, So what they do is they give us a core product that is functional. If we want to go and excel with that, then we can. So
Jailbreaking it.
It's not really jailbreaking it, but it's like if you're into tuning, and it's like JDM, right? So you get a Nissan.
Yeah.
And you take that Nissan and you throw superchargers and turbochargers and forged pistons and all that sort of stuff in it to turn it into the wickedest beast on the road. But that's what we do with it. So one of the proofs of that, so we've got a data analytics team that's embedded in our rail team.
Yep.
They use a lot of Python. They use a lot of open things like QGIS and things like, or QGIS. As a company, we're kind of based on an Esri platform for GIS, but there's a lot of other stuff out there. But the common things we do use, Python, C#, C#.NET, and JSON.
Right.
So JSON becomes quite a sort of interoperable format, because a lot of software can read and write a JSON format.
Do you think that'll be a trend for the future? Do you think that they'll start slowly?
It's already a trend now. So.
Oh, really? Oh, there you go.
So hear that, everyone who's doing civil and a bit of coding.
Yeah.
Jump on
Highly
JSON.
recommend Python as a language to learn. Like I said, I'm 25 years into my career. I'm starting to learn the basics of Python now. Like, I don't understand at this point how to turn that into an API tool.
Okay.
But I can certainly go through and do conditional statements and basic math and things like that, or even some complex trigonometry using Python. Cool. It just extends the capabilities of what we can do. A good example of that, I had some colleagues in Perth ring up a smart man by the name of Brent Burgess. He rang me up and said, look, we want to do these noise walls and retaining walls. What can we do? So I went through a 90-minute conversation with them, a bit of a screen share, and showed them some basics of what we could do with Dynamo. And that was basically grab some alignment geometry out of Civil 3D, grab a tin surface, and start placing UC columns and some basic paneling for a noise wall.
Cool.
Brent took that away and extended the heck out of it.
Turned it into a drift car.
So he took the Skyline and basically started through this iterative process. Now, he did it in a really innovative way, and this is actually something that's not a technology innovation. It's actually just a workflow innovation. And this is actually a way I like to work as well, because it means that our projects actually provide instant return on investment for our business. He's taken that basic boilerplate, or what we call a boilerplate. So it's just a very quick example of something you can do.
Okay. Sort of like a prototype?
Very much a prototype, or just a singular sample. He's taken that and then he's run it through an iteration where he's now got noise walls fully drafted with long sections and profiles, just running through Dynamo. And then the brilliance of this guy is they're going, no, we've got to be able to do this quicker. So every iteration was, okay, we did
typical
it with Dynamo.
engineer.
Typical engineer. And he's
That's what we need.
He's actually a coder as well. So he's taken that, gone, I've done a lot of things in Python inside Dynamo, but it's even though like 2 minutes was too long for him. So he's taken all of that and turned it into an API tool. So he's changed it over into C#, using Visual Studio, turned that through, written it all out in C#, created an API, now a custom tool that's part of our WSP suite, and he can now go and model kilometres of noise wall in about 6 seconds.
That is
Instead of 2 minutes.
So cool.
Instead of 2 minutes. And the interesting thing about all of that entire innovation happened over the course of about 160 hours on a project. But not only did he deliver the project, he's delivered 3 iterations of a digital tool.
Yeah, true.
So, to anyone out there that's going, how do I innovate in my company? Use the time you've got allocated and budgeted. Yeah, you're going to have to put a bit of personal effort into that. But use that time, maybe speak to your manager if you're not in a position where you can actually make that decision for yourself, but use that time to innovate something that's actually going to make your life a lot easier and actually produce results where we can now go, hey, the next project, I can have a wall in 6 seconds.
And the other companies have to wait.
The other companies have to wait 150 hours.
I imagine that's so crazy for something like a company because it changes how they operate so much, and that gives companies such an advantage over other companies. I'm guessing that helps win things like contracts and stuff like that so much more.
Yeah, absolutely. It helps us, we'll still budget what we do. Like if I take M6 as an example, it's a design and construct project, very tight time frames. Everything's got to be done to the same quality. But we've got $100 million excavation machines waiting on site for information. That stuff's burning a couple of $1,000s an hour. And then you get through points in time where in any engineering project, you only know what you know at the start. So as you get further on in, you start to know more of what you didn't know at the start. So different interfaces come through. So if we take a retaining wall or a noise wall as an example, the level of information or the quality of the information we get underground, where those piles need to be, may not be great. It might be a GIS thing that's been digitized off a plan that's been developed in 1969. And I have had to convert in the past feet and inches plans from the early 1950s or 60s into metric. To
manually?
We sort of manually, but we had to
be on software.
We had to put it into software so we could actually check the water film depth on some rural roads after flood recovery. So making sure that when you turn around that corner, you're not going to skid off the road because there's too much water.
Can you run that through simulations, or is that just sort of based off of someone who's very experienced in that area and can look at that and go, that's going to cause accidents in the future?
It's basically a simulation. There's a calculation that's determined by the authority. So Queensland TMR have a specific water film depth calculation. It's the same calculation we use in Transport for New South Wales. The software vendors have come on board and created tools that basically you go and do your where the water flow path is. So you still have to understand how to read a contour and where water's going to flow. Autodesk have developed a little thing they call water drop. So you just put a point on a surface and it'll try and trace where that water drop's going to go to.
That's pretty cool, actually.
It's good. It's really good. You'd probably still have to do a bit of manual checking on that. Other software vendors, you just go and read your contours, draw your line. It will do the calculations for you and spit out a report that you can send to the authorities and say, hey, yep, we're compliant, or no, we're not.
The thing I love about this digital software is that it's taking years and years and years of traditional integrated knowledge and putting it into something that everyone can use and access, instead of having to go up and ask some senior guy who's been doing it for 50 plus years and gets a little bit sidetracked and you're trying to get the information out of him. Instead, it's so accessible, like you can just run it through simulation.
Absolutely, but
crazy.
I'll defend the old white-haired 50-year experience guys though, because they're the guys that taught me.
Yeah.
Totally,
and they taught me without using software.
Yeah, it wouldn't be anywhere here today. without
No,
that.
exactly,
Yeah.
and it's probably another thing to be wary of is having known how to design a road without just trusting a tool. It's like you still have to know how to design, which is interesting because the software's so powerful now that we can go throw parametric assemblies down something and have this really wicked looking thing in a pretty short period of time. Almost there is some tools that have been developed on gaming engines. So InfraWorks comes from Autodesk. That was their in-house developed tool based on a gaming engine. The same thing with Concept Station from Bentley. Really rapid conceptual tools, but you can make something look really good, but it's so wrong.
Is it functional? Yeah. That's the thing I want to ask you too. Do you think it's dangerous doing that sort of method? Because you're going to create, I feel like, maybe some lazy engineers, and who's going to be there to double check that?
Well, I mean, hopefully we'll just actually start to get a lot more time to do that back checking.
Yeah, okay.
As you know, in Queensland, there's a system called RPEQ. RPEQ engineers actually have to certify a design, so it can't just be we've got an awesome looking bridge that looks fantastic in a gaming engine, but its engineering properties are woeful. I think a few years ago there was a miscalculation on a bridge in Canberra.
Oh, really?
They didn't allow for the weight of wet concrete in the formwork. So they've poured the deck and the formwork's given way. It can be quite dangerous if we just trust the tool, but that's where we need experienced engineers to not just be experienced engineers, but actually start to get up to speed with new digital tools, the analysis that's being put through there. We've got some amazing analysis tools that basically will give you whatever finite element stress analysis you want, but you've got to understand how to interpret that and then push that back in and then ultimately check it to say, yes, as an engineer with adequate experience, I'm satisfied that the properties of this are correct and it's not going to fall down.
It's funny too, because so many people immediately think, AI software, it's going to take my job, I'm going to lose my career, blah, blah, blah. But realistically, I think it helps you so much. It's such an important, valuable tool that it's becoming sort of recognized now that it's your buddy, it's your partner. This software, you can get places without it, but with it, it's not replacing anything that you did before. It's actually helping you so much.
It is, and that's the thing. Like the ability for us now to produce a lot more options and a lot more certainty, and that's the thing. Like in an engineering world, we're one of the highest paid industries. In Australia. I think we're second to medicine at the moment. So it's the salaries are very good, but that also comes with a lot of risk, like personal risk on your certifications. It also comes with a lot of long hours, of long hours. Well, I mean, just the sheer magnitude of work and calculation and overtime that has to happen. And that's where things like the D&C or design and construct contracts actually start to get quite wearing. I call it sprinting a marathon. You're constantly running so hard just to meet your deliverable. But tools like AI, well, we haven't really integrated AI too much, or they're starting to get some machine learning in. But just in terms of parametric things and computational design, that doesn't take your job. You're exactly right. It's your buddy. It helps you because you can go, man, I had 40 hours of work to do on this one thing this week, but now I can actually run my script or my automation, which is going to give me the answer in about 10 minutes. Which means then I can actually focus on things that I need to focus on and go home at 5 o'clock.
It's like a co-pilot.
Yeah, pretty much.
Well, on obviously engineering's changed a lot. Like recognizing that you were once a young engineer, moving your way through the industry, what are some hurdles that you had to jump or risks that you took that helped you get where you are today?
Yeah, it's actually a really good question and a great discussion topic, because I know as a young designer, I thought I was brilliant. As you should. You should have some confidence about what you do. A couple of managers that sat me down and gave me some really good home truths that cut me to the core for about 3 minutes, and then I realised they were right. The first one was actually in my first job. So I started as a young designer working for Transport and Main Roads in Cairns. My boss there, I was fresh out of university. I thought, yeah, look, I've got my, at that point, diploma of civil engineering. Look, I'm awesome. And he goes, you actually know nothing.
Yeah.
And he was 100% right. And it's like, he didn't mean it to be nasty to me at all. He actually meant it to go, yeah, you've got your university degree or your diploma or whatever you've got or your advanced certificate. It doesn't really matter. But what you learn in TAFE is the basic principles to teach you how to actually apply things in the real world. I walked out of his office going, oh, great. But
back to square one.
But he was 100% right, because none of the things that I actually learnt in university were applicable to my job.
Yeah.
They were in the terms of how you solve problems, how you go and interpret standards, how you research things that you need to apply. But if you go through a standard civil engineering degree, you'll go through things like, hydraulics and hydrology. You'll go through soil mechanics and pavement, structures 1, 2, 3, 4, all of those things, which are actually teaching you a very general, broad base on how the whole world of civil engineering works. We actually did some drafting subjects where we we did actually have to design a road. I went out in the field and did some surveying as part of my course. It was a very long time ago, but it actually taught you how things all work together. It might not have been applicable to how I designed a road today, but that knowledge back then, I still use a lot of that knowledge now and understand how things like structures actually fit in.
I'm guessing it's very similar to driving a car. You know how to drive the car, but you don't know how the car works. And you're taught how to drive the car, and you don't know how it works until it breaks down and fails on you. And then you've got to pull it apart and find out how it works. And that's when you get that deeper knowledge, I guess.
But then you go through that whole excitement. One of my biggest hurdles was actually looking at people that had 10 years more experience than I did, thinking I was as good.
You don't know anything, you're just a dinosaur.
Well, that's the thing. What makes you better than me? And then I got that 10 years of experience more, and then I look back and go, man, you're a little arrogant thing, aren't you? But experience, or understanding your experience and being willing to actually ask questions. Ask as many questions as you can, and find people who are willing to help you as a mentor. So that's kind of the things in the hurdles. Was a few of them were having to be adaptive to new technology. So I first learned a software called MX, which for the old people used to be called MOS, or Model of Strings and Surfaces, and then became MX Road, and now that's actually progressed. It's been retired now by Bentley, but they've replaced that with now Open Roads. So I learned that first up, and then a few years in, I had to learn 12D, and it's like, okay, but by that stage in life, I realised that the skills that you learn in one piece of software transfer directly to another. It's a slightly different methodology, but it's not how well you operate software that actually counts. It's how well you can apply your design knowledge and your engineering knowledge to using that piece of software.
Back to like the university principle, I guess. We're fresh out with those skills, but they're not hard skills.
That's right.
I guess.
So you might spend 12 months getting yourself up to speed in another software, but you're actually learning on the fly how to do it. I've had to learn Civil 3D as well. It's a very different process. You've just got to learn those different things and be adaptive to the tools you need for your job.
I'm guessing you just keep finding yourself back to square one in some sense when you jump on new projects and stuff. Something that I've learned, and I'm in the young, is what I call the kindergarten principle, where the first day of kindergarten, you get there, you don't know anything, you don't know anyone, and then you go through, and then you get to primary school, and then you're in grade 6, and you're about to go into high school, and you feel king of the world, like, oh, I'm in the highest grade at the school, and then you get into high school, and you're back down at year 7, and you're back starting again, and then you get to year 12, graduate university, and then you're back and then you're back at first year university, and you're still at the bottom, but like, I feel like it's those processes between that's where you really learn how to operate and adapt fast. Right. And I think it's such a crazy process because it just keeps happening through your life and like through your career.
And the thing with that is that the level of guidance actually reduces as those steps increase. So you think about kindergarten, you've got a huge amount of guidance and whatever from your kindy teachers. They're actually still handing you your food to eat and things like that. You get to primary school and all of a sudden you've got to actually have your own food to eat. Remember to eat it. That's kind of the hurdles through that was actually overcoming not knowing how to do something. and using the intelligence of your own brain. We're highly intelligent creatures, but using that and then using the things that you learn on how to apply it, which I think university is actually teaching you, yes, engineering skills, but it's actually more teaching you how to interpret a standard, because reality is one of the biggest things you'll learn when you leave university and come into an engineering world. A standard is based on a perfect principle where, an intersection in a road is perfectly perpendicular, or a structure is perfectly parallel and no deviation. You've got to learn how to interpret that standard into all kinds of different scenarios, but still maintain compliance. And that's another big hurdle for people, and it all comes down to ask questions, find people with more experience than you, latch onto them. The sacrifices to get where you want to go, and this is actually a big thing in industry. And I was getting on a plane in Sydney a few weeks ago, and I was just having a chat with an old guy, just in general, walking down, and I said, yeah, look, I said, this is my last flight for the year. And he goes, yeah, I've been doing this 40 years. He goes, oh, these young people today. And I'm thinking, oh, yeah, okay. But honestly, in terms of sacrifices, if you want to further your career, and if you want to actually get ahead in engineering and personal life as well, there's going to be opportunities that come your way. And if it means you've got to get on a plane for a project, don't say no. If your company is offering you that opportunity, it's actually something that they will trust you to go and do that. And then I remember, I had kids really young. My wife and I had our kids very young, and it got hard through when they were sort of 11 and 12. I started traveling a lot more for tenders and things like that. But at the same time, that sacrifice that it wasn't just me making a sacrifice, it was actually my family as well. But without that, if I'd said no to those opportunities, there's no way I'd be sitting where I am today. But one thing I learned, and I was away 5 days a week back then because I was quite young and didn't know how to negotiate. I was like, yeah, okay, I need to go to Sydney. I was there for every week for 6 weeks, fly down Monday, fly home Friday, because I thought, I've got to do that for my reputation, which is true. But if you can manage that with your family, don't say no to the big opportunities.
Definitely.
Especially things like the newer stuff like BIM. 2014, I was part of a working group on how we were going to address this BIM problem, or what is BIM. No one knew what it was. No one knew how it was going to benefit
Sounds
us.
like a new energy drink or something like that, doesn't it?
Pretty much, yeah. It's like Buzz Cola. That's what you should get. It does exist, actually.
Sponsor?
Maybe. But it's kind of like that comment we were talking about before, about once upon a time we thought the world was flat. Once upon a time we had no idea what BIM was, or what it could even turn into. And something inside me said, you can't let this go. So at the time I was quite happy. I was the principal designer for SMEC on the Gold Coast, doing really well, had a great reputation. I was basically one of the guys they called as the first call if a project went haywire somewhere else. So it was constantly, hey, can you be in Sydney tomorrow? It's like, yep. But that's the thing. It's like, well, those opportunities then led to a reputation that said, hey, this guy can help us in this scenario. I was still one of the most junior people in the conversations. We were talking with, and I've got a great deal of respect for this man. His name is Neil Evans, who at the time was the director of new business and strategy for SMEC, and the investment that he put into me personally, and also my colleagues, and alongside of him was a guy called Steve Macbeth. They're the old people that will just invest in you, and it's like ride that wave. But there's something in me said you can't let this go, and they'd advertised the national BIM manager. I got no idea what I'm doing. We're still so fresh in this. But I said I want to be a part of this future. So they actually gave me the job.
Wow.
It meant that I had to spend the next 2 years flying in and out of Sydney. And they said, well, if you're going to take this role on, you've got to work on Northwest Rail. At the time was our first major project. And I said, okay, well, I can do 3 days a week in Sydney. Does that work for you? So that's how I ended up getting into this BIM world, which has morphed into digital engineering. And
I guess you got to see the golden egg and the goose before you just see the goose as a goose.
Yeah.
If that makes sense.
Pretty much. I mean, if your gut's telling you don't want to miss out on this, act on that FOMO.
Yeah.
it's a healthy piece of FOMO if you're there
Yeah.
going, I'm actually really passionate. I don't know what's driving me to this.
Yeah.
Don't look at what it's going to cost you. You can worry about the cost later. But if you, it's like the Northern Territory's old marketing campaign. You never go, or never know if you never go.
I like that one.
So if you think an opportunity might be good, it's worth that sacrifice. Even if it doesn't work out, it's worth the sacrifice to at least work out if it's going to happen or not. We're in a very risk-averse industry. We have to be as engineers. But you can also be very forward-thinking, but still not risk-averse, but risk-aware.
Yeah.
And you can pull the pin on that at any time.
Calculated risks.
Risks. You go, well, what's this actually going to do for me personally? I can't say that the last 8 years or 9 years of my life have been the easiest, but they've been the most rewarding.
It's that balance, I guess.
It is
like
that balance.
Chucking on the scales, risk, reward. Just get both of them on the same sort of page.
So
I want to ask as well, so what actually got you into engineering? So when did you start getting an interest in engineering? Like as a young kid, you just pulling things apart and like, I like doing this. So like, did you look at a bridge and be like, oh, I want to build that one day?
Yeah, actually I was about 7 years old, I think. I used to enjoy drawing suspension bridges as a kid. And I had 3 goals in life. I had 3 career directions that I thought this is what I want to do when I'm a grown up. One of them was driving big rig trucks. Because I love big rig trucks. I'm glad I didn't pursue that. But so that was one. I'm thinking, I'm going to drive a Kenworth. The other was technical drawing. My father's actually, he was a technical studies or manual arts or woodworking, metalworking, things like that.
Yeah, right.
Actually, he was a teacher, high school teacher that taught that. Actually retrained as an architectural draftsman. So we've got this technical drawing kind of thing in our family already. So that was the other one. I'd for fun go and grab an A3 piece of paper and draw suspension bridges, like really big ones.
Did your teacher like see that one day and be like, oh?
No, teachers never saw it.
Oh, really? Secret. My secret suspension bridges.
Yeah. I've got an interesting topic which I'll mention after the third option. And the third option was actually professional drumming.
They're all so different from each other.
They are so different from each other.
Yeah.
But luckily I've been able to pair 2 of them together. So
cool.
obviously the technical drawing one worked out, and no, I don't drive big rig trucks. But I do enjoy playing drums in my hobby time, and that's something that I do regularly every weekend, and it's a lot of work, but it's so much fun.
Yeah.
So being able to pair a passion with a calling, if you like.
It's so cool.
But interesting topic on school teachers. And this is something, if there is a school teacher out there listening, please don't write kids off when they're young. One of my brothers in year 10 had a teacher who said, you have no place in science.
Wow.
I don't know what he did to annoy this lady, but that's what she told him. Well, I can pronounce to the world that same brother now has a PhD based in sea ice physics, and he's one of the only people in the world that's actually been on expeditions to both the North and South Pole.
That's the biggest middle finger if I've ever heard of one. That's insane.
Yeah, I mean, if that's an inspiration for other people as well.
Wow.
You know, he's now one of the world's leading geospatial experts.
Wow.
You know, he might not be working for a big company, but he's certainly gone through the Australian government. He's worked for the Australian Antarctic Division. He's currently in Norway, working for the Norwegian Polar Institute. So yeah, even if the cards are down or whatever, just keep at it, because he just pursued, even in the face of an adult telling him you've got no future in this.
Yeah, the teacher couldn't see the golden egg.
The teacher couldn't see the diamond underneath the rough edges. You know, so
I think I've heard of this one before where like someone it's just not a story, but it's more of like a metaphor where like there's a monkey, a rhino, a hippo, and a leopard, and then they say first place winner is the one that can climb to the top of the tree. Yeah. And I guess that's very much like sometimes the education system where everyone is very extremely different, but they set the standard and say that this is what victory means and this is what success means. Sort of.
Yeah. But it also depends how you look at it, because, you know, obviously for your brother, it made him more determined to become the most successful scientist he possibly could.
Yeah.
Whereas for some people, it could just completely crush them and they would never study science ever again.
Yeah, true.
Exactly. And it's all about your determination.
Yeah.
And your self-belief. I actually failed high school maths. I mean, it was maths AB or maths 1-2, depending on which state you were.
Yeah.
I couldn't for the life of me understand calculus or matrices.
Yeah, I really reflect on that because I'm the exact same. In high school, I did the lowest level maths possible. Even through university, still failed most of the math courses. And then now I'm at Boeing.
Yeah, exactly.
Like a couple of years later. And
it's crazy.
Like I could never foresee myself being here because of what my previous failures were, I guess. And I was like, oh,
exactly. And that's probably a key point because I fail every day.
Yeah.
And I'm not afraid to fail every day. And that's what innovation is about. That's what innovation, Thomas Edison failed 9,999 times to make the light bulb. He just worked out 9,999 ways not to make a light bulb.
Yeah, no, definitely.
You've got to take that same approach in innovation, engineering, the whole thing. Don't be afraid to fail. Learn from that. Go, okay, so that didn't work. So how do I change something for it to work? The key to that is understanding when to let it go.
Yeah. Okay.
But sometimes, and this is what I find that's very interesting with human people, I'll be mulling over a really tough thing. I can't work out the solution during the day, and I'll go to bed at night. And I'll be laying there just about asleep, and the light bulb just goes bang.
Yeah.
That's how you do it. And
it's when you whip out the notepad and you're like, quick, write that down.
Well, the thing is, the solutions are so simple.
Yeah.
And you're there going, how did I not think about that? And so it's probably a good thing just to switch off. If you're having a real tough time trying to crack a solution.
It's such a weird thing how that happens.
Off.
It's the same with me. Lay down at night and I just reflected. I'm like, oh, why don't I just do this differently? And then I wake up in the morning, I'm like, what was that thing?
Yeah, better write it down, guys.
Notepad whip out the notepad app and just quickly just jot that down. It's like
probably a real key piece of advice is don't be afraid to fail.
Yeah.
So on that note, do you have any advice for students considering engineering or still at uni or even in high school who they're not quite there yet? Like they don't quite know if this is what they want to do.
Yeah, I mean, there's multi-sides to engineering. Engineering becomes a very technical, propeller hat type. It's actually something we're struggling with as an industry at the moment. Is the amount of women that are coming through. I had a conversation with someone yesterday, and we're listing out who our key people that would need to be in a workshop or a meeting we're going to be. And she said to me, she goes, where are the women? I said, that's a good question. The pool is growing, but it's going to take a lot longer to grow. And there's some very, very, very smart young girls out there, just need encouragement, need the right push to get in. And it's like, traditionally we'd have, talking back decades, there were still very intricate pockets of our engineering industry that would naturally attract women into it, like environmental science and things like that. The opportunities are huge. So for young kids out there or people that are thinking about engineering, don't leave it too late for a start. You've actually got to kind of decide in about year 10 or before year 10 to set up your subjects if you want to go straight into university. If not, you just go through some bridging courses afterwards. I think you can
that was me. I didn't decide until I graduated.
Yep. And that's fine too. It's like it's easier if you can decide when you're younger, because then you can start to get into the programs that businesses are starting to run now with high schools, and we're guiding universities with their content, and how does that affect industry?
I think that helps so much because it sets expectations.
Yeah.
Like, what can you expect to be doing on a daily basis and that sort of thing. If you had told me back in high school, what does an engineer do? I would have zero expectations. I'd probably say bridges, roads. I'm not sure.
But it's so diverse now.
Yeah.
You go into things like urban and landscape design. While that sits under an architectural banner, it's still part of the engineering sort of, cohort. So if you're a bit more art driven, but you're sort of technical driven as well. People used to say, oh, how hard is it to build a road? You just chuck a bulldozer down there and throw some black stuff on.
Obviously.
10 minutes.
But, like changing that paradigm of getting the right minds into the industry, and it doesn't matter anything else, but, what drives you? If you're fascinated by roadworks, then jump into roadworks or jump into roads and start looking into how you can progress into roads. It's
fascinated in suspension bridges.
Yeah, well, the road industry has roads, alignment, geometry, drafting. There's technical sides that can go in, and generically, a cadet drafter needs no qualifications. You can come in, you can test the waters doing that. I mean, try and get into undergrad programs if you can.
Yeah.
Like I said, companies like us, and I think Lang O'Rourke did this as well, quite heavily out of Sydney. They worked with an all-girls school to try and encourage girls that, construction is cool. Road design can be quite artistic. It can be very technical. It can be a lot of multifacets. There's heaps there. It's not just all maths. People think about engineering as all day, every day calculus and heavy mathematics and really hard problem solving. And it's like, yeah, when you get to a technical principal level or technical executive level or technical director level, that your ability to do that, and it depends, like your geotech engineers, our tunnel engineers are brilliant people, very mathematical driven. Our road alignment people, while we do a lot of mathematical stuff, it's like trigonometry, algebra. If you can handle year 10 maths, you can definitely become a road designer. That's me. That's exactly me.
Especially with the help of programs like BIM and stuff like that, and all these other software that's coming through.
Yeah, and that's the other side of it too, like computational things and generative design and coding. Coding's becoming a huge part of the engineering industry. So yeah, go get an engineering degree and do a dual degree in programming.
Opens so many doors.
Yeah, that'd be
Opens
great.
tons of doors.
Yeah.
That's probably the next generation of engineers, is people that learn the engineering side of things but also learn how to code.
So they can automate it.
Yeah.
But also have an understanding of how it operates and how it works
yeah.
as well, I guess.
Yep.
It helps so much. Understanding how the car works before you drive it, sort of
Yeah.
thing. Like that was one of the things that deterred me even just starting engineering, because I'm naturally a creative person, so is my parents and stuff. But like I was thinking, I can't just do maths all day and sit there and do technical stuff. And the first few years of uni, they were like that. But you got to make your own sort of opportunities as well, I guess, and it helps so much once you can understand that.
I mean, even down to business development and project management and things like that. So you don't actually have to be a highly technical person to become part of the engineering industry. You do for obviously your technical disciplines of engineering, but there's a whole bunch of other stuff out there. There's innovation development, there's business development, there's financial and accounting, and there's a whole bunch of stuff there that you can actually utilize in that. And
it's not until you start to really dip your toes in engineering that you realize how multifaceted it is. There's so many sides of this problem. It's to every problem, but in the engineering specifically, there's so many sides that I've found so far.
Definitely.
Like attacking it from a creative side, a technical side, like just all of that. It's insane until you get in there and you're like, wow, this is huge.
Even visual arts and visualization, gaming development. It's starting to become like, with the advent of with digital engineering, BIM, digital twins, visualization, VR, AR, MR, all of the R's. We still have to have RR.
All of the R's and all the dimensions.
Which is real reality. So we've got augmented, virtual, mixed. There's still a bit of real there. It's such an exciting time to become an engineer or think about becoming an engineer. Look, I mean, you look at what we're looking at now, smart cities. Is it Saudi Arabia that's building this 170 kilometre long
that thing's awesome.
wall? There's going to be needing a whole team of engineers, a whole team of asset managers, a whole team of really, really intelligent people. We're in a super innovative time where data drives everything we do now. So
I think it's becoming less product focused and more environment focused in terms of creating these massive, humongous systems and integrating these systems instead of just a single product that's being engineered by a single company and then implementing that into the environment. It's creating this entire system from scratch essentially, and like these tools help so much to get around that, I guess.
Even if we look at the way the M6 runs, it's a twin bore tunnel 70 meters under the ground. Which pops up and it's got a bit of surface roads and all that, but offset, but it's a beautification. So it's taking infrastructure that can be quite ugly and actually making it assimilate into that environment, so it's almost imperceivable that it's even there.
I'm guessing it adds like monetary value and also physical beautification value as well, I guess.
Yeah, well, I mean, it's kind of more to be less intrusive. It's kind of hiding in plain sight.
Like the invisible ventilation towers that we don't even know about. Well, like obviously you have a lot of different projects you're working on. What is one way that you stay focused? How's your work-life balance? How do you balance all this, all the different work that you do?
That's actually a good question because I've been primarily focused on one project for 18 months. I guess if you can get together a to-do list, and something that I learned, but it's just a little simple trick, is write out what your tasks for the day are. Even if it's virtually, even if it's in your head somewhere, just go, I've got to do X, Y, and Z today. Set yourself your own little deadlines. You are going to have people that come up, want attention straight away. But the one way that I've found to deal with that was actually to go, you know what, because he'd demand it straight up, and they go, well, it's going to take, I've got to stop what I'm doing now. That's going to take attention away and cost time. I'm going to have to restart what he's doing there and then finish that off and then go back and restart this other thing. You end up in this really big time sink. And before you know it, it's 5 o'clock and you should be going home, but you've still got 3-4 hours worth of work to do.
I think that helps to set up expectations so much, and you can start the day off knowing what you've got to do, and then at the end of the day, it's sort of like a little check, a report on yourself, being like, have I done that today, and have I finished those things? And if I have, then I can sleep well tonight.
Well, that's right. I mean, you've got tools like Planner. We actually use MS Planner quite a lot. I've got a system set up. Every single model that we do needs a validation.
What's MS Planner? Just quickly.
Microsoft Planner.
Microsoft Planner is so good.
Okay.
So
it's on Teams.
It's on Teams.
As well.
It's part of SharePoint.
Yeah. Right.
If you're in an organisation that is on Office 365, you'll have Microsoft Planner.
Yeah, it's great. It's got like checklists and everything. And
That's cool. But the whole idea of your personal checklist is if you do have people that come up and just sort of throw demands at you because it's going to happen, is the easiest way to deal with that is just say, look, I need to finish the task I'm currently on, but then I can actually slot you in next. And every time I did that, I got through my whole list on the day. They'd be going, but this needs to go to the minister and blah, blah, blah. And it's like, yeah, well, great. You still got your stuff to the minister and I still got my focus finished.
How good is that?
I guess it's similar to like a fast food
Supply
scheme
chain.
where it's supply chain where you're making a big meal and someone comes in, orders a burger, and then they're like, where's my burger? Where's my burger? And you're like, I'm making a pizza, man.
Yeah,
Like,
once the pizza's finished, I'll start your burger. But I can slot your burger in before the next pizza.
yeah,
And
true.
the burger's going to take you 5 minutes, right?
Yeah.
But it's going to take you 20 minutes to stop making the pizza, put that aside, and then start the burger, which takes you 5 minutes. But then you've got to pick up that same pizza again and restart the process. So
Yeah.
I try and block out an hour every day out of office for lunch. It probably 90% of the time doesn't work, but at least you've got that backstop of trying to put time in your day for you to actually take a break and take a rest. I'm one of those people that I'll work like a maniac Monday to Friday until I burn out, and then I've got to have a rest. But I won't work weekends.
Yeah, no,
I think that helps so much because you know that working through the week, you're like, okay, get through this, got the weekend coming up, just blast through these tasks, and then I've got time for myself, family, and everything
definitely.
else like
That's
that.
it.
And even just like you mentioned with the 1 hour lunch break, like you're working on a task and you're like, okay, I've got lunch next, so let's just finish this and then go and grab some lunch. And then like, it helps so much instead of just sitting there hammering away at this one task. And
Absolutely.
like you say, getting lost in this time sink and you're like, what's going on?
I actually find myself, I have a Bluetooth headset. It's fine if I'm working from home because I can just walk up calls through speakers at home. But working in the office, I've got a Bluetooth headset for a specific reason, so I can actually get up and walk around.
Yeah, totally.
Sitting at your desk for long periods of time actually becomes really draining. But even if you're just standing at your chair, not attached to your desk, you can walk around while you're
Go
in a
make a
meeting.
coffee.
You can go and get a coffee or
totally.
a tea if your Bluetooth range is long enough.
And then someone just calls you today and you can just like answer and sort of do things.
Yeah,
or,
well, I mean, you've got a number of different options, but
no,
I
you
know
don't want to be
that-
in the bathroom when that happens. Wearing your headset. Sorry, mate. Just
definitely
give me
turn
5
it off for
minutes.
that. But yeah, having that ability, that freedom to actually get up and walk around. I used to have people we're in the Gold Coast office here, and I'd have people that were just looking at me funny because I'd get up from my desk mid-meeting and I'd be talking away and I'd just be over pouring a glass of water, but I'm still on the phone, or I'd stand at the plan table in the middle of the office. But I just found that worked for me, and it helped you actually focus. Doing something that's like unconscious
Yeah, right.
while you're in a deep focus really helps.
Freaks me out so much when I'm on the train. People sitting there talking to their mates. I'm like, what did you say? And they're like, oh, wait, no, they're not talking to me. Don't worry.
Yeah.
Just on that, so you're talking about the quote-unquote dinosaurs before and the people that used to teach you.
Yep.
What sort of skills and stuff did you learn from them that were regarding leadership and communication? Like, is there any traditional values in terms of that you've seen that you've used yourself, or anything new that you've picked up? Because obviously engineering is very teamwork focused, very leadership focused, project focused. how do you, like, what sort of important skills should people know?
Probably the most important skill is drop your ego.
Yeah.
Everybody's in this team for a purpose. And I know you had a chat with Peter Villick. He might have... Peter was actually one of my colleagues at SMEC, and I have a great deal of respect for Peter, actually. Obviously, he's Macedonian, and I had to learn in myself how to deal with different cultures. And once you crack that nut of what someone's saying to you might sound very abrasive, but they actually got a heart of gold. And once you crack through that, you've got to dig deeper underneath the surface of the words that someone used, because we work in such a multicultural environment. English is not an easy language. It's the hardest language in the world to know, because it's like they're three different meanings for one word, you know. But how someone actually means to say something versus how they say it, and you've got to dig deeper and actually get to know those people. And then you realize that they're actually just like you. They're trying to do the best job they can possibly do. The thing for me is absolutely respect. Respect people for people. When you walk into a tough conversation, walk into that conversation thinking, how would I like them to talk to me? That's how you should approach someone else, is always think, if they said that to me, how would I feel about it?
Yeah, definitely. I think that's so important, just being able to put yourself in someone else's shoes.
Yeah.
Because it makes such a difference.
It does, and you don't know what their commute to work was like this morning. You don't know if they've had a family tragedy. You don't know what their personal life is doing right now. All you know about them is the 8 hours a day that you see them in the office. That's probably something that you learn over a lifetime. Definitely the things that I've learned from my predecessors is patience, because when you're dealing and instilling knowledge with people that don't have as much as you, they don't have as much as you. So they're not, if I said to you guys, I want you to go and design that contraflow interchange over on the motorway.
Sure.
I'll just pull up BIM.
Yeah. It's like, I'll just BIM it. And it sounds a little bit offensive, but it's so true, because people's intelligence levels are just in different directions. They're not that somebody's less intelligent or more intelligent. Sometimes
like emotionally, or,
they're just focused in different areas.
Yeah,
so
totally.
The general mantra is try and treat it like you're speaking to an 8-year-old. You've got to explain it to an 8-year-old, because you've got people that are very focused on finance. I don't know how to be a banker. So if a banker's going to say to me, hey, you've got to do that compound interest, yeah, what? What?
Yeah.
It's the same thing with engineering. It's like we're very, very technical. So when you've got new people coming through, I mean, obviously you treat them with respect, but you've also got to understand what their level of knowledge is. So you've got, say, someone who's a graduate, guide them, teach them. You've got to realise that they don't have 20 years experience. They've got none.
I think it's such a fine line to walk down, because if you swing too much on the other side, then they might think you're talking down to them as well. And like not understanding what their actual skill set is before you talk to them can sometimes cause that.
I have a young graduate working as part of my team on M6 at the moment. We've had a couple of young graduates, and the one thing I find works is you just give them a task and let them do it. Let them ask the questions they need to, check in on when you need to check in. But if the work's being done, let them keep going. And then once that first task is done, then give them another one. Give them something a bit more complicated. So one of the worst things I find is when you get sort of mid-level people, and I had to be careful about this when I was in that bracket, sort of 10-year experience, that you become a little bit condescending and you become a little bit too arrogant, a little bit too proud. And you'll find yourself actually talking to people that are above you, because you actually start to become a little bit competitive with people that are above you, because you want to be in their job.
And you're sort of testing yourself then.
You're testing yourself, seeing how much you can sort of beat your chest. But that's sort of, you've got your experience, you've got a few feathers in your cap, you've got a few stripes on your arm, but it's like that's in that time where you're going to learn how to actually interact with people above and below. Because until that point, you've only really interacted with people below you and your immediate management. When you start getting into becoming that next level of management, then you've actually got to start dealing with more senior management. So it's like, respect for people's knowledge, respect for people's situations, and actually listen more than you talk.
Yeah, so that's something Peter Villick said.
Yeah, that is actually something
listen
he said.
More than you talk. Oh, actually, before we ask our last question, what is some opportunities at WSP, if there's any undergrads or grads who are looking for possible employment here one day?
We run a graduate intake program. Watch out on LinkedIn. Look at our home pages, wsp.com. But yeah, we certainly run a fairly large and extensive graduate intake program. We only have limited places, so it is a bit of a lottery. But drop into an office. Drop into one if you know where it is, and say, hey, is there someone I can talk to? Is there a technical team lead I can talk to? We certainly need a lot more drafters. We're certainly trying to grow our staff pooling in digital engineering, or what we call digital engineering activities, of digital leads and digital coordinators. And that's probably another opportunity if you like some technical things but don't really want to be an engineer. Model coordinators. We're screaming for them. There's programs you can run. We'd probably want you to go through a bit of a TAFE course. I know there's a lot more focus because it's part of our digital strategy of the section that I'm in, is actually starting to get into more TAFEs in universities and things like that, because there has been a bit of a lull. Particularly in the more technical side, so the technologist area, with a lot of fully qualified degree engineers coming through, drafters / technicians, structural drafting, modelling. So if you enjoy mucking around with software and you enjoy actually designing things, but you don't really want to go through the whole mathematical journey, then yeah, there's plenty of opportunities there, and that's what I'd recommend. Chuck your CV in.
That's so good.
I think you might have done that. But that's how it rolls. So there's either the graduate intake program, or put yourself out there.
We just have one last question. This is something that we ask all of our guests who come on the podcast, and that is, it's quite a big one. If you could solve one major problem in the engineering world, so globally, that you have noticed within your industry, what would that be, and how would you attempt to solve that?
Oh, that's a really good one, and I've got to be careful how I answer it. I actually think that the one problem that I'd love to solve is actually empowerment, because being so technical and so standards and so compliance driven as an industry, it can create an environment where it's very much, I can only do what my boss tells me I can do. I'd actually like to see more people take a lot more initiative personally. Things like self-learning after hours. We've got training budgets that we can allocate a certain amount of hours during the week to put people on training courses, and it's one of our obligations as an employer, is to make sure that our staff are given the adequate resources to be adequately skilled, particularly as we're moving on in newer technologies and newer process.
And knowing how to access that as well when you need it most, I think.
And knowing how to access it, yeah, exactly. Or even having the opportunity to access that. This is a lot of what I've done over my career. Just self-development. Go and be really inquisitive. There's a reason why you pursued an engineering degree. And it's because you wanted to learn stuff. You wanted to investigate and innovate and change the world. For me, what I'd love to see more of is that personal investment in yourself. So jump on Google, get involved in LinkedIn groups, follow, for want of a better term, technology influencers. Follow people who are involved in technology development.
Listen to some podcasts.
Yeah,
listen to the Engineering Buzzcast. But yeah, that's probably the biggest thing I'd like to see solved in it, because from what I see in my role, I'm involved, like my role is capability development. I would love to go, hey, some people are brilliant at this, and we've got some brilliant young grads who just take, the example I gave earlier of Brent. He's not a young grad, he's actually a principal technician. There's other young graduates who you give them a little bit of a bite of the cookie and they'll go and create a new recipe. But they don't do it out of corporate training. They don't do it out of, I've got a project code that I can build to. They actually go and sit down after hours or in their lunch break or whatever and go and investigate something that's actually going to take what you've given them and invest that and get a return.
That's something so satisfying to see, because, it comes directly from passion. And drive. And it's so nice to see that.
And that's what's actually going to create people who change the world.
Yeah, that's awesome.
If you're not passionate about your job, it's just a job. If you love what you do, you never work a day in your life.
That's so true.
It's very true. It's an absolute jam-packed episode. I think we've just covered every single topic to do with a career in engineering that we could possibly think of. So thanks for that. talked some really important points about personal development and technical side of things and your own background. It's been really interesting to hear.
Yeah,
So
I hope all our listeners got something from that, because I sure did. That was great.
yeah, I personally learned a lot from that. So thank you so much, Chris,
Thanks
for being
so
on the
much.
Engineering Buzzcast.
Thanks for having me on. It's been a pleasure.
No worries.
Happy to impart some old head experience
No worries.
and talk about Nissans.
Yeah, absolutely.
Awesome.
Thank you very much.
All right, thanks for that, Chris.
Thanks, guys.
And with all that said, if you've enjoyed today's episode, please don't forget to share this with your mates or colleagues who also might benefit from these discussions as well. And if you can, just leave an honest review or rating on your preferred podcast platform. With all that said, you've been listening to the Engineering Buzzcast with your hosts, Jacob Primus and Daniel Hardy. And until next time, see you in the next episode.
See you in the next episode.
See ya.
The top job is that of the engineer. This requires a great amount of ability and training in mathematics. And you should have some courses in